In a trapezoid, there are two sides that are parallel. Those two sides are called bases. The two non-base sides in a trapezoid are called legs. Since these sides are parallel, we know something about these angles. These two angles are going to be supplementary, because they are consecutive interior angles. And that will also be true for these two angles. Because they're consecutive interior angles between two parallel lines, they're going to be supplementary. Now in an isosceles trapezoid, all of the properties for a regular trapezoid are true. So we have two bases that are parallel, and we have two legs. And in an isosceles trapezoid, those two legs will be congruent. Now when that happens, we have a lot more information. These two angles here will be congruent to each other, and these two angles will be congruent to each other. These pair of angles and these pair of angles are called base angles. And our base angles will be congruent in an isosceles trapezoid. We also know something about the diagonals of an isosceles trapezoid. The diagonals of an isosceles trapezoid don't quite bisect each other, but the way that they intersect makes them congruent to each other. So the diagonals are congruent and proportional. We do have some congruence within the diagonals. They're not quite bisected, but this segment is proportional to this segment, is proportional to this segment, and this segment. There are some properties working with the midsegment of a trapezoid. The midsegment, if you remember from the midsegment of a triangle, is connecting the midpoint of two sides of the triangle. Now, if we have triangle ABC, and M is the midpoint of AB and N is the midpoint of AC, we had that formula that said the measure of MN was going to be 1/2 the measure of BC. So if this side was 100, MN is 50. Well, we also have a midsegment in a trapezoid. The midsegment connects the two midpoints of the two legs of the trapezoid. So if I have trapezoid A, B, C, D with midsegment MN, to figure out the measure of MN, I'm still going to use the 1/2, but I need to include both bases. So if AB was 50 and DC is 100, MN is going to be halfway between 50 and 100, 75. Mathematically, we're taking 1/2 of the measure of AB plus the measure of DC. The second property of the midsegment, if you remember from the triangle, when we had a midsegment, the midsegment was going to be parallel to the side, which gave us some congruent angles. And those angles were congruent because they were corresponding angles. In a trapezoid, when we find the midsegment connecting the midpoints of the two legs, we also get congruent angles. And those angles will be congruent because they're corresponding because the midsegment will be parallel to all the sides, to the bases. Now let's switch gears and talk about kites. A kite has congruent sides that are consecutive, and it also has at least one pair of opposite angles congruent. Now a lot of students look at a kite and they think that these two angles will be congruent to each other, but they're not always. In a regular kite, they don't have to be congruent. If they are, then we have a rhombus or a square. We also know that in a kite, the diagonals have to be perpendicular, and one of the diagonals has to be bisected. Now those same rules apply to a concave kite. We have consecutive sides that are congruent. We have one pair of opposite angles that are congruent, and you can tell here that this angle is definitely not congruent to this angle. And our diagonals also have the same properties. If we connect our diagonals, they're still perpendicular, and one of the diagonals is bisected.